Hello! Today's lesson is order of operations, but before we get to the order of operations, we want to make sure that you are aware of how to evaluate powers. So here as example 1, we have evaluate 3 to the 5th power. And how we do that is we know that, hold on, let me get a better color there. We take 3 to the 5th power, which literally means to take 3 times itself 5 times. So 3 times 3 times 3 times 3 times 3. All right? So what we can do is we can just kind of go in order. We know 3 times 3 is 9, and 9 times 3 is 27. And perhaps at this point you don't know what 27 times 3 is. But what you can do is you can take these two 3s. So these first 3s are 3 times 3 is 27, and then 3 times 3 is 9. So then 27 times 9 will then give us 243. All right? Or you can use the calculator, and the calculator will do 3, and then there's this little button on your calculator. It kind of looks like they call it a caret key. It's right here. And then a 5, and hit enter, and that'll also work. I'm not really, it's like a little bird when people draw birds, but they call it a caret key, and if you use that key 3 to the 5th power, you'll also get the same result. Alrighty, so what I would like for you to do now is the do-it-yourself problems. There's A, B, and C, and we're going to continue. If you need more time, you can just pause the video and you can complete your do-it-yourselves. All right, so as I was saying, this is about order of operations, and a lot of you have already heard there's an acronym out there that helps us remember the order of operations, and that is PEMDAS. And there's all kinds of different little words that people use. Please excuse my dear Aunt Sally. Please excuse my dear son's absence, because you can reverse these S and A. So there's different ways that you can remember that. But this is, PEMDAS. And I didn't want to tell you this. It's a little tidbit of information for you. There is actually no mathematical reason why we actually have PEMDAS. There's no rule that says you had to multiply or divide in this particular order. But what was happening back in the day, and I'm talking about way, way back when people weren't doing math, what was happening is that people in different places were getting different answers for the same expressions. So for example, you have this kind of an expression, and depending on how or on which operation you did first, everyone was getting different answers. And so in order to create some consensus so that everybody was getting the same answer, the powers that be back then, I'm sure it's a committee of people got together and decided that they would create an order so that everybody would get the same answer all the time. And that's kind of how order operations happen. So anywho, just a little bit of facts there for you, history if you will. But this is PEMDAS. We have parentheses, which ask you to evaluate expressions inside grouping symbols. And grouping symbols can be parentheses, but they can be brackets, they can be division bars, they can be square root symbols, and we'll get to that as the examples come. Exponents. You evaluate all the powers. And then I put these two together like this because they can technically go in any order, multiplication and division. You multiply, and that's why I highlighted here, and or divide from left to right. So if division comes first, left to right, then you would actually divide before you multiply. So these could actually go in any order depending on their position left to right. And the same is true for addition and subtraction. You can add and or subtract from left to right. So again, if subtraction comes before addition from left to right, then you would actually subtract first, not add first. So there you have it, PEMDAS. Make sure that's in your notes. And we're going to do some examples. So here we go. We have parentheses and are the first thing we look for, grouping symbols. And we don't have any grouping symbols in this case. So what we're going to do is we're going to move on to the next, which is E, which stands for exponents. And we do see that there are some exponents here. the 2 squared. So we're going to evaluate that first. Everything else gets rewritten. And instead of 2 squared, I put 4 plus 14. The next thing I have to do is any multiplication or division from left to right. And in this case, we don't have any multiplication, but we do have division. And it's right here. And we know that 8 divided by 4 is 2. And again, we rewrite the 16 minus, and the plus 14 gets rewritten. And then we do addition and subtraction from left to right. And again, you'll notice that in this case, when I read from left to right, the negative comes first, the subtraction coming before the addition. So I am going to actually 16 minus 2. Why is that not changing? Sorry. 16 minus 2 is 14, and then we add another 14, and our final answer is 28. For example 2, 28. All right, so in a similar fashion, I would like for you to now try the do-it-yourself number 2, A and B, in your notes. Make sure that it's in your notes so that I can check it in the next class period. All right, so now we're going to do more of the same, but they're going to get a little bit more complex. You can see that now we do have grouping symbols. So we're going to start with parentheses or grouping symbols. So I'll start with A here. So we know that we have 10 minus 6, and 10 minus 6 is 4. Put the 5 back, put everything else back. All right, and now we want to go exponents, but there are no exponents in this case. So the next step is multiplication or division from left to right. And we do have division, and we also have multiplication. But as we're going from left to right, the division comes first. So we are going to go 4 divided by 2, which is 2. That's left to right. 5 times 4 is 20. And then we have our plus in the middle. Okay, so division and multiplication from left to right. And the last step is to add or subtract. In this case, we only have one thing to do, which is add. So we get 22. For example 3, part A. And now we have our next one, and this is a 6, by the way. Sometimes people confuse my 6s for B's or 4s. I don't know where they get a 4 from, but I've seen it happen, so I just want to be clear there. We're going to do 2 plus 3. Again, we're doing grouping symbols first, and that's 5. And we have a little square symbol. There's still a minus. There's a 32. We still have these brackets and the 6. The next step is to have the exponents. So again, we see that there's a 5 squared right here, which is 25. So we had 32 minus 25. Still have our brackets and a 6. And then we're going to go 32 minus 25. And that's going to give us 7. And lastly, 6 times 7 is 42. So one of the things that you will notice in this example is that you actually had 2 sets of grouping symbols. You had your parentheses and your brackets. But you want to start with the innermost parentheses first. And that's why we did the 2 plus 3 first. And then we have to stay inside. And we're not going to multiply by 6 because we have to also deal with these grouping symbols. So we had to stay inside the grouping symbols before we could carry on. So there we go with that guy. And then this last one I wanted to make a little a note of, because sometimes we can think that grouping symbols are only parentheses or brackets. But what you have in C is that this division bar is actually acting as a grouping symbol because it is separating the 2 groups, the top and the bottom. So we're going to start with the top as our grouping symbol, and the first thing we have to do on the top is exponents. So we have 2 to the 3rd power, and 2 times 2 is 4, and 4 times 2 is 8. So 2 to the 3rd power is 8, minus the 5 over 15 plus 9. All right, then we want to do any multiplication or division, but there's no multiplication or division up here, only subtraction. So then that's what we do next. 8 minus 5 is 3. And on the bottom, 15 plus 9 is 24. And our last step would be to simplify, because we know that 3 goes both into 3, it goes into itself, and it also goes into 24. So our last step would be to simplify our fraction, and that means that 3 goes into 3 once, and 3 goes into 24 8 times. So our final answer is 1/8. And that is how you evaluate expressions of this sort. Now I'd like you guys to do the do-it-yourself number 3. Again, evaluating each expression. There's an A, B, and C in your notes, and make sure that you have them when you come back to class so we can check them. And this is our last example, and we are going to evaluate, and this time we have an expression, but we're also substituting values. They've told us that x equals 4, y equals 5, and z equals 3. What I have done is I've underlined each of the variables with a different color because I like to color coordinate what I'm doing. So what I'm going to do, the first thing you want to do is go to your expression, and you want to write the expression, but you want to put the variable values into the expression. For example, I have 3x squared, but I know that x is 4. So I'm going to take and say times 4, and then according to the expression here, that's 3 times x squared, and then plus parentheses 2, y is 5, and that's in blue. So 2 times 5 plus z, but z is 3, and that's in an orange. So that would be 3 cubed. Okay, so I've rewritten the exact same expression, but I've replaced x with 4, y with 5, and z with 3. And now it's just going to become nothing more than what we were doing earlier in the previous examples. So, parentheses first. So we're going to come over here first, and in these parentheses, we can see 2 times 5, or we have to do exponents first. So we're going to go to the 3 cubed first, and that's 3 times 3 is 9, 9 times 3 is 27. And then we have the 2 times 5 is 10. And then everything else just gets rewritten. Okay, and then lastly, or not lastly, but at least in these parentheses, the last thing we have to do is 10 plus 27, which is 37. Now as we look at our resulting expression, we have exponents again, so we want to do those first. So we're going to get, right here, our 4 squared is 16 times 3 plus 37. And 3 times 16, I believe, is 48. So 48 plus 37. And then our very last step is to add 48 and 37, which is a whopping 85. All right? So that is how you evaluate when you're given values for the variables. This is your last do-it-yourself example. There's an A and a B, and once you have completed this do-it-yourself problem, then you will have completed your notes for this section, and I will see you in class